This tutorial covers the gsolve functions in graph mode on the Casio FX-CG50. For more tutorials with this calculator, visit parkermaths.com/CG50. Before you start this tutorial, it's recommended that you're confident with drawing graphs on your calculator and adjusting the settings in the view window. If you don't think you are confident with those, it might be worth doing those tutorials before coming back to this one. Let's start by setting up a function to work with. We'll go into graph mode, number 5, and we'll enter the function x to the power 4 minus 6x squared minus 4x plus 1. Let's take a look what that looks like. Okay, most of the graph is on the screen, but we can see at the moment that it's going off down the bottom of the screen here. So we're going to adjust the view window first to make sure we can see all of the curve. We press F3 to go into view window. Let's start by using the standard preset and see where that gets us. That's a bit better, still cutting off a little bit at the bottom though. So maybe we need to manually adjust the minimum y value, let's say minus 20. Now we comfortably have both of the local minimum points on the curve. The first gsolve function we're going to use is to find roots. So we press F5 for gsolve and then F1 for root. That finds us the first root on the curve here at x equals minus 1.90. To find more roots on the curve, we use the directional arrows. Pressing the right arrow gets us the next one at -1. Then there's another one at 0.19 and so on. It's worth noting that if I hadn't managed to get the whole of the graph on the screen, if there was a root that was outside of the view that I can see, then gsolve won't be able to find that root. Also, at the moment I've only got one curve on the screen. If I have two curves on the screen, there's an extra step you need to take in order to select which curve you want, and I'll show you that later in the video. Next, we're going to use gsolve to find local minimum and maximum points. We press F5 to enter the gsolve menu, and we press max F2. That will find us a maximum point. For the maximum points, you get an x and a y coordinate. In a similar way, we can find the minimum points by going gsolve min. This time there are two. It finds the one on the left first, and then if we press the right arrow, it'll find the second minimum point as well. Interestingly, unlike with roots, your calculator can find local minimum and maximum points that are outside the view that you can see on the screen. Next, we'll do the y-intercept. This one's nice and straightforward. We go gsolve y-intercept. There we go, y equals 1. We can also use gsolve to find specific points on the curve. For example, if we go gsolve and then to the next menu by pressing F6, we get options for ycal and xcal. If I press ycal, it allows me to enter an x value, for example 3, and it will calculate the y value at x equals 3. In this case, y equals 16. Notice that although my x value is on the screen, even though the y value is not, it's still able to calculate it. In a similar way, we can go gsolve, and then we can go xcal, and it allows us to put a y value in. We could put y equals 5 in, and it will give us the x coordinate when y equals 5. The next gsolve function I'd like to look at is finding the points of intersection between two curves. To do that, let's enter a second curve. We'll press exit to return to the list of functions, and I'm going to enter 3 minus 2x. We'll go back into the graph view, and we can see on the graph there are 2 points where the line intersects the curve. To find these points, we press gsolve, and then we go to intersect, F5. It finds the first one up here, the coordinates are shown at the bottom, and then if I press the right arrow, it will find another one to the right. Finally, I'd like to show you the difference it makes if you've got two curves on the screen and you want to use one of the previous functions we've looked at. For example, to find a root, I go into gsolve and root like I did before. But notice that now one of the curves is flashing. That is the currently selected curve. If I was to press EXE right now, I would have selected the blue curve to find the roots of. Instead though, I'm going to press the down arrow and you'll see the line is now flashing. If I press EXE, it's going to find me the roots of the line. In this case, there's only one at x equals 1.5. That method of selecting a curve works for any of the gsolve functions that work with a single curve.